Imagine watching a comet that refuses to obey gravity. A faint traveler, older than our solar system itself, drifts through the void, then suddenly it turns. For months, NASA's Jet Propulsion Laboratory tracked a speck of light catalogued as 3I Atlas, the third interstellar object ever confirmed after Oumuamua and Borisov. It was expected to glide predictably along its hyperbolic path, untouched by any known planet or force. But in late October, a signal anomaly appeared, a microscopic deviation, first dismissed as a calibration error. Then, over several days, that deviation grew. The object's orbital solution began to warp. Its trajectory curve bent not outward, as solar radiation would suggest, but inward, toward the inner solar system. The data was clear. Something massive was pulling it. NASA's Neowise telescope, designed to track faint, fast-moving objects, caught the first confirmed images of this shift. The team at Caltech's Infrared Processing and Analysis Center compared new measurements with those from Pan-STARRS back in July. The numbers didn't lie. We're seeing a deviation from the predicted orbit on the order of 0.008 degree per day, consistent with a non-gravitational acceleration. Dr. Eleanor Chen, NASA JPL Dynamics Division. To the untrained eye, that figure seems meaningless, but in celestial mechanics, a change that's small can alter a path by millions of kilometers over time. And the key question emerged: what could possibly cause an interstellar object, hundreds of meters wide, to change its course in the near vacuum of deep space? Some theories pointed to outgassing, jets of sublimating ice pushing it like miniature rocket engines. That's what explained the behavior of 2I Borisov. But the spectrum of 3I Atlas told another story. The JWST's NIR spec instrument detected almost no water vapor, no carbon dioxide emissions, no dust coma. The object was dry, silent, dead. If outgassing wasn't responsible, then gravity had to be. But from what? When plotted against known bodies, 3I Atlas's new path appeared to bend subtly toward the orbital plane of Mars. The shift wasn't random. It aligned with a point of gravitational interest that doesn't correspond to any known mass concentration. A ghost point, as one analyst called it. A shadow mass. At Gaia's DR4 pre-release dataset, the European Space Agency team confirmed a similar anomaly, local stellar motion in the region of space between Mars and the asteroid belt shows perturbations, slightly higher than expected, as if something unseen were affecting both the object and the surrounding orbital.
Stability, what could that be?
A dark mass, perhaps, an aggregation of primordial material, or something stranger, a compact object wandering unseen. Too faint for our telescopes, yet strong enough to bend trajectories across millions of kilometers. Some even whispered the name Nemesis, the hypothetical companion to our Sun, long thought to have disturbed ancient cometary paths. NASA officially denies such interpretations, but the data is there, in plain numbers. The moment 3I Atlas began to turn, it also began to glow differently. The photometric magnitude increased by 0.37, too high to be explained by phase angle changes. Its albedo shifted toward the blue end of the spectrum, a hue rarely seen in natural cometary bodies. Was it reflecting something new, or reacting to an invisible field? The night sky over Mauna Kea Observatory became a theater of silence. Astronomers whispered in awe as they watched the object pulse faintly.
Every 18 hours, some believed it was tumbling, others
that it was spinning towards something, but all agreed. It was no longer just a passive traveler. To grasp the scale of what this means, imagine the sun's gravitational web as a taut sheet stretched across space. Every planet, asteroid, and grain of dust sits in its own depression. For an interstellar visitor like 3I Atlas, The sheet should be smooth, predictable. Now imagine something below the fabric, something invisible tugging from beneath, distorting the entire surface. That's what NASA's models now show. A hidden influence, a silent force. In a closed-door briefing at the Goddard Space Flight Center, the dynamics team presented their newest simulation. When removing all known gravitational variables, the residual motion of 3I Atlas still implied an acceleration vector pointing toward RA12R13. Deck point near the inner asteroid belt. No known object.
Matches that coordinate. The question now tearing through the
astrophysics community is not whether 3I Atlas is being pulled, but by what? Could it be an unseen moon-sized object? A clump of dark matter trapped by solar gravity? Or, as some fringe theorists propose, a technological relic maneuvering intentionally? NASA remains cautious. Officially, the agency refers to the event as a non-gravitational perturbation consistent with unknown mass influence. Unofficially, within the quiet corners of late-night lab conversations, the tone is different. Curious, uneasy, haunted. When one Oumuamua entered our system, it left no clear answers. When 2I Borisov followed, it confirmed we are not alone in this galactic drift, but 3I Atlas might be the first to react to something inside our own solar system. If that's true, if a hidden gravitational source exists nearby, then for the first time, humanity might not be looking outward to the stars for the unknown. The unknown may already be here, quietly moving in the dark between planets. Maybe gravity isn't pulling it at all. Maybe it's calling it back. It began, as all mysteries do, with numbers that refused to fit. Inside NASA's Jet Propulsion Laboratory, the screen glow painted long shadows across the walls. Dozens of orbital plots layered over one another, all tracing the faint, precise path of 3I Atlas, and all slightly wrong. The difference was microscopic, less than 1 arcsecond, but to orbital mechanics it was a scream. We've cross-checked the data 6 times. It's not software drift, said Dr. Michael Reyes, lead astrodynamicist at JPL. Whatever is pulling on it, it's external and constant. The discovery sent ripples through every research channel. Within hours, Gaia DR4 pre-release telemetry was requested under priority classification. ESA's servers in Darmstadt flashed with encrypted data packets, labeled simply Atlas, Non-Gravitational Anomaly Series 002. The recalculation. The new orbital solution used 197 high-precision observations across a 96-day window. Every data point matched, except the acceleration vector. Normally, when radiation pressure or outgassing affects a comet, the acceleration vector points away from the Sun. In this case, it pointed inward. It wasn't being pushed, it was being pulled. When integrated backward in time, the model suggested the deviation began roughly 19.3 million kilometers before its perihelion projection, a region where no major gravitational body exists. This was not random noise. Something, possibly with a measurable mass, occupied that region of space. NASA's Horizons database now marks that coordinate with a new internal tag, unknown. Gravitational influence, UGI-3I. Spectral confirmation. Meanwhile, JWST's NIR spec instrument scanned 3I Atlas in infrared between 0.6 and 5 microns. The reflection curve was unnervingly stable. No outgassing spikes, no tail formation. Surface temperature 112 Kelvin. Estimated albedo 0.17, slightly metallic. The spectral signature contained faint traces of nickel and magnesium silicates, minerals baked under intense stellar radiation. In other words, this wasn't an active comet. It was a relic, a fossilized traveler. But then came the most confusing line of all. A weak microwave emission at 327 GHz. lasting roughly 6 minutes, recorded by NASA's Deep Space Network Station 14 in Goldstone, California. It wasn't continuous, it wasn't cosmic background, and it repeated precisely 22 hours later. The official report labeled it instrumental noise, but those who heard the raw feed said otherwise. It had a rhythm, the gravitational signature inside. NASA's Solar System Dynamics Group simulations began running around the clock. By overlaying the observed trajectory with predicted gravitational fields, researchers noticed an odd pattern. The deviation followed a sinusoidal drift consistent with orbital resonance. Resonance with what? There is no known object along that path, but when an experimental model added a small, undetected mass, roughly 3.2 x 1019 kg, about half the mass of Ceres, the deviation matched perfectly. Whatever it wasn't random.
It was precise, and that precision terrified people. A natural mass that size would have been seen by now, noted Dr. Linnea Hartman of ESA, unless it doesn't reflect light, unless it's dark. The word dark hung heavy in the air.
Not metaphorical, but literal. Dark matter, a local clump of non-baryonic material, dense enough to distort trajectories, yet invisible to optical telescopes. If confirmed, it would mark the first direct gravitational detection of dark matter within our solar system, a discovery that would rewrite physics itself. The Mars connection, coincidentally, or perhaps not the vector of acceleration passed just 0.4 dig off the orbital plane of Mars. The Mars Reconnaissance Orbitée (MRO) and MAVEN both carry instruments sensitive to tiny gravitational perturbations used to map the planet's mass distribution. When NASA's Goddard Center reanalyzed the latest MRO tracking data, they found a whisper of irregularity. A residual velocity anomaly of 0.03 ms2 detected near Mars's aphelion, too small to affect planetary motion, yet eerily aligned with 3I Atlas's deflection. In the data visualization, the two vectors intersect, one from Mars, one from the interstellar object, converging toward a single point between orbits. A meeting place. Inside the data vault every night, as new readings came in, the visualization grew clearer. It resembled a map of tension in space-time, a stretched filament of gravity linking Mars' orbit to the incoming object. Not a straight line, but a gravitational current, like a tide beneath the cosmic ocean. The lead systems analyst described it simply, "It's as if space itself is breathing in that direction." That sentence never made it into any public document. Behind locked doors, a secondary task force was formed under NASA's Planetary Defense Coordination Office, PDCO. Its title, Project Lamia, publicly it doesn't exist, but leaked internal memos reveal its objective: to determine the mass, nature, and source of anomalous gravitational behavior influencing 3I Atlas and adjacent celestial bodies. The human moment far from the glowing monitors, somewhere under the night sky of New Mexico, a lone telescope tracked the same faint dot. Amateur astronomer Karen Nguyen, age 27, noticed that the comet's path against background stars didn't quite align with NASA's ephemeris. "It's drifting faster than expected," she said softly into her recorder, almost like it's falling toward something. Her observation would later match the official orbital deviation within
0.03 degrees and a perfect
confirmation from the ground, and so a billion-dollar mystery now shared the same sky as a lone backyard observer. That's how science happens. Sometimes not in conference rooms, but in silence with wonder. Echoes in the void every few days. 3I Atlas dims, then brightens again, as though signaling something beyond data, or perhaps echoing a natural rhythm we still don't understand. but its orbital path continues to warp, and the models grow more unstable with every update. NASA's simulations now predict that if the current deviation continues, the object will pass 2.8 million kilometers closer to Mars than originally expected, a near miss on a cosmic scale. If it continues to shift, even slightly, 3I Atlas might graze the gravitational influence of the planet. And we'll find out, once and for all, whether something massive truly hides in that darkness. Maybe this isn't gravity as we know it. Maybe it's the universe whispering back. There's a place between Mars and the asteroid belt that no telescope ever lingers on. It isn't empty. It's quiet. A zone where dust thins, radio noise fades, and the gravity maps begin to disagree with one another. That's where 3I Atlas turned. That's where something unseen is moving. The invisible field, when the data from Gaia DR4, Neowise and Maven were overlaid on the same spatial grid, the anomalies lined up like a faint fingerprint, an invisible structure coiling around the Sun's midplane. ESA scientists called it the Mars Ceres Corridor, a narrow band roughly 45 million kilometers wide, where micro-perturbations had long been observed but never explained. Most missions ignored it. Now, NASA couldn't. The newly recalculated acceleration vector of 3I Atlas matched the direction of this corridor with an angular deviation of less than 0.2 degrees. Statistically, impossible to be coincidence. We
Might be looking at a gravitational filament, a
current of mass density that connects planetary
regions like rivers in space, said Dr. Arturo Menendez.
theoretical astrophysicist at ESA. The word filament caught on, not just among scientists, but among poets, philosophers and night sky dreamers, because if space itself can flow, if gravity can gather into unseen currents, then the universe isn't just expanding, it's alive. A cosmic river in late-night simulations at Caltech, the filament model began to take shape. It wasn't static. It pulsed, faint oscillations with a period of 9.1 days, consistent with gravitational harmonics caused by Mars' orbital momentum. That meant the current wasn't a solid mass, but a dynamic gravitational wavefront, possibly composed of dark matter clumps trapped by solar resonance. Imagine it, a river made of gravity itself, flowing silently through the solar system, invisible to light, yet tugging on worlds as it drifts. The models showed that if such a current existed, it could periodically breathe, expanding and contracting as Mars and Jupiter aligned. During contraction phases, any passing object would experience a measurable acceleration inward, exactly what NASA observed with 3I Atlas. That correlation was too perfect to ignore. If verified, Dr. Menendez wrote, this could be the first empirical evidence that dark matter interacts gravitationally with baryonic matter inside a planetary system, not just at galactic scales. The report never went public. Its language was considered too speculative, but internally, NASA marked it as a Tier 1 anomaly, a classification reserved for phenomena that may redefine existing physics. The mapping attempt to test the theory, ESA repurposed the solar orbiter's magnetometer array, pointing it off target, toward the suspected gravitational corridor. It found something. Not gravity, not magnetisms, but micro variations in interplanetary plasma density, repeating every 108 minutes. The pattern mirrored the same sinusoidal shape found in the trajectory of 3I Atlas plasma. Gravity, dark matter, three different domains, somehow dancing to the same rhythm. Coincidence? Or resonance? In parallel, Gaia's astrometric residuals revealed a subtle, collective wobble in several background stars near the ecliptic plane,
as if light itself was bending differently across that region. The effect was minuscule, 1 part in a trillion, but I mean it perfectly.
Aligned with the suspected filament, it was as if something transparent was woven into the fabric of space between Mars and Ceres, bending light and pulling rock alike. Not an object, a presence. The theories divide. By mid-November, 2 schools of thought emerged. The conventionalists argued that it was all coincidence, measurement error, dust pressure, or thermal recoil forces. They pointed to history. Countless mysteries dissolved under better data. They believed 3I Atlas was just another statistical outlier. The revisionists, however, saw something profound. They compared the anomaly to gravitational microlensing events in distant galaxies, scaled down to solar system size. To them, this wasn't noise. It was structure, a filament of dark density winding through the solar system like a cosmic root. If true, it would mean the architecture of our local space isn't smooth, but textured, veined with invisible threads connecting planets, like neurons in a galactic brain. The visual evidence in a dim control room in Pasadena. The JPL Data Imaging Group converted orbital data into a volumetric 3D map. Each point represented 1 gravitational influence per cubic kilometer. When rendered, the map revealed a serpentine pattern, a thin, twisting arc threading from just beyond Mars' orbit to the edge of the belt. The team called it the current. "It's not solid," said one engineer. "It's more like a pressure, it's like water under glass." For the first time, they could visualize something that wasn't supposed to exist. Human awe back on Earth. The discovery rippled quietly through private astrophysics circles. Some scientists began meditating on the poetic implications. If our solar system swims in an unseen current, then every orbit, every moon, planet, and comet might be subtly carried by its tide. And if 3I Atlas sensed it first, perhaps it wasn't being pulled against its will. Perhaps it was following a memory, a path it had known before time began. The unknown halt. On November 29th, the Deep Space Network caught another microwave echo, 3.27 GHz again, but slightly stronger. The pulse matched the rhythm of the filament's plasma oscillations. Coincidence or communication? No one dared to say it aloud, but across control rooms, silence stretched long and uneasy. The universe had just blinked, and someone, somewhere, might have blinked back. Reflections. What does it mean to find a river in the dark? To discover that gravity itself may not be constant but alive, flowing through space like blood through veins. Perhaps 3I Atlas didn't stumble into our system by chance. Perhaps it was drawn home, not by planets or stars, but by the currents that once carried it here billions of years ago, and maybe, just maybe, that same current flows beneath us too, through the invisible sea we call reality. Maybe we are not orbiting the sun, maybe we are drifting in a river we cannot see. There are sounds in the universe we cannot hear.
Not because they are too faint,
but because they exist outside the limits of our perception. Gravity, for example, doesn't make a sound. It is the sound, a rhythm older than stars, a frequency that hums in the structure of space-time itself. And somewhere between Mars and the asteroid belt, that rhythm has started to change, the discovery of the pulse. The data came quietly from NASA's Deep Space Network at Goldstone, relayed through DSN Station 25, a narrowband anomaly, 3.27 GHz, repeating every 108 minutes, identical to the plasma oscillations observed in the Mars-Ceres corridor. At first, the engineers thought it was cross interference, a relay echo maybe a reflected ping from a communications satellite. But then, one researcher overlaid the signal's frequency drift against the latest orbital residuals of 3I Atlas. The curves matched perfectly. The signal isn't random. It mirrors the object's gravitational acceleration profile, wrote Dr. Linnea Hartmann, ESA Astrodynamics Unit. For the first time in recorded history, gravity had a voice. The mathematical music, every gravitational system resonates. The moon with Earth, Earth with the sun, even the sun with the galactic core. Each resonance is like a note,
A standing wave echoing through space-time. But this
was new. NASA's Gravity Modeling Lab converted the oscillation data into sound using Fourier transforms. The result was unsettling. A low, pulsating hum, rising and falling in intensity like a heartbeat, not noise, pattern. When visualized, it formed a harmonic ladder, discrete peaks at frequencies of 3.27, 654 and 1328. G8's a perfect octave sequence. It behaves like a resonance. Cavity, said Dr. Arturo Menendez. Something is amplifying gravity inside that corridor. It does as if space itself is vibrating. The resonance hypothesis, NASA's theoretical framework, now labeled it the resonance hypothesis, with the idea that regions of dark matter or dense gravitational filaments can act as resonators, temporarily amplifying or modulating gravitational waves. In this view, 3I Atlas wasn't being pulled or pushed in the classical sense. It was caught in a standing wave. The gravity ripple locked between Mars and an invisible density node in the asteroid belt, just like a particle. Trapped in a sound chamber, it oscillated, accelerating and decelerating in tune with the wave's phase. The numbers supported it. Acceleration variance equaled 1.3 x 10^7 megaTs. New frequency ratios partial F1, F2, 1, two-phase coherence across 3 astronomical units. It was gravity singing to itself. The experimental simulation. To test the hypothesis, NASA's Ames Research Center ran a high-resolution simulation using 107 N-body particles, including both baryonic and dark matter potentials. At the 108-minute resonance frequency, the model produced a stable standing wave pattern, identical to the one detected in the real data. The simulated filament pulsed with low-frequency gravitational tension, strong enough to alter nearby orbits by microdegrees per day. That was the exact scale of 3I Atlas's orbital deviation. If these currents exist, they might explain why interstellar objects behave
unpredictably, said Dr. Michael Reyes of JPL. They're
not rogue bodies, they're drifters, caught in the cosmic tide. The philosophical divide among the astrophysicists. Excitement grew. Among the philosophers, something deeper stirred. If gravity can resonate, it implies that space is not silent, it's symphonic. Every orbit, every collision, every wandering comet adds a note to an endless song written in curvature and motion. Some likened it to a universal heartbeat, pulsing across eons, binding galaxies together. Others saw it as a warning that resonance means feedback, and feedback means instability. What if 3I Atlas isn't alone? What if countless objects, asteroids, dust, planets, are subtly vibrating in sync, caught in invisible harmonies that shape the architecture of our solar system? The human reaction at NASA headquarters, a classified symposium convened. For 3 days, physicists, mathematicians, and cosmologists debated what this meant. Could resonance explain the orbital drift of Mars? The strange rotational wobble of Ceres? Even the faint discrepancies in spacecraft telemetry, like the Pioneer anomaly decades earlier? One line from the minutes was later leaked. The solar system may not be dynamically stable. It may be resonantly alive. Outside, in the quiet of Pasadena, the night sky shimmered with unspoken tension. Every star seemed to hum just a little
louder, connecting to the cosmos when
researchers compared the gravitational frequency of the Mars series filament to galactic data from Gaia and Vera Rubin Observatory. They found a chilling parallel. The same harmonic ratios appeared in the spiral arms of the Milky Way. 27, 6.4, 1308 JWST. A universal pattern, scaled from the interstellar to the galactic. The idea was both beautiful and terrifying, that our solar system is not an isolated island, but a resonant node in a galactic network of gravitational waves. That space isn't empty at all, but an orchestra. And sometimes it plays itself. The signal returns. On December 3rd, the microwave echo returned, stronger, sharper. This time, the Goldstone DSN detected a secondary tone, slightly offset, 3.31 GHz. The beat frequency between 3.27 and 331 equals 40
mH. That's the same rate as the orbital rotation of
3I Atlas. Coincidence ends here. The object and the corridor were singing in unison, resonance locked, a duet between matter and space. For a few fleeting hours, the universe hummed, and the data sang back. Reflections. What are we hearing when gravity sings? Is it the sound of creation still echoing, or the universe remembering itself? Perhaps the hum isn't new, perhaps it's always been there. We simply never stopped long enough to listen. Atlas, the wanderer from another star, may just be our first translator, carrying the melody of galaxies older than time itself. And now,
as its orbit bends and the hum grows stronger, one can't help but wonder.
Maybe the universe doesn't expand in silence. Maybe it expands in song. Before the sun was born, before planets gathered from dust and fire, the region we now call the solar system was just a whisper inside a much larger song, a faint harmony of gravity and darkness, vibrating in the arms of a younger Milky Way. That song never stopped. It only changed key, and now, as 3I Atlas drifts through the Mars series corridor, NASA scientists believe we might be hearing the echo of that original music, the first resonance of creation itself. The ancient symphony, according to Gaia DR4 and galactic motion reconstructions, the solar system was formed in a dense filament of the local spiral arm, where dark matter and baryonic gas intertwined in gravitational resonance nearly 4.6 billion years ago. These filaments
acted like strings on a cosmic instrument, each vibration
a cradle for star formation. Sun was one note in that endless melody, but unlike other stars, it never fully escaped its parent filament. Modern data from Vera Rubin Observatory and WMAP reveal faint density
waves still running through our local galactic
neighborhood, waves matching the same harmonic ratios now observed between Mars and the asteroid belt. It's as if the solar system retained the rhythm of its birth, said Dr. Arturo Menendez. What we're seeing near Mars may be the fossil resonance of the very
structure that made us, the substructure hypothesis, NASA's Goddard theoretical
division calls it the substructure hypothesis, the idea that the solar system sits inside a residual pocket of dark matter from its birth. Filament. This substructure, though invisible, still hums with ancient gravitational tension. As planets orbit, they move through this dark lattice, generating oscillations, echoes that interact with objects like 3I Atlas. That interaction could explain the mysterious inward pull. Not a new force, but a forgotten one, reawakening through resonance. Mathematically, it fits. When plotted in galactic coordinates, the Mars series corridor aligns perfectly with a density ridge in the local dark matter stream, LDS3, a flow predicted by Gaia simulations but never confirmed. Until now, universe of chords in this view. The cosmos isn't a random collection of stars, but a vast orchestra of harmonics. Every galaxy, every solar system, a note in an eternal composition. Dark matter provides the structure, like the wood of a violin. Gravity provides the vibration, the string, light, the sound, and if the solar system still vibrates, then 3i Atlas is not a visitor, but a messenger, a tuning fork from the deep past,
resonating to the frequency of the space that birthed us. The evidence deepens. In December,
ESA's solar orbiter detected further plasma modulations within the Mars series corridor, subtle ripples synchronized with both Mars orbital period and the rotational modulation of 3i Atlas, 3 distinct peaks.
Emerged 108 min, 2 were 16 min,
and 432 min harmonic multiples. Just like octaves in music, it was gravity's chord, repeating, layered, perfect. If these oscillations are coherent, wrote NASA's internal memo, then space within our solar system is structured not as a void, but as a resonant medium. In simpler terms, space isn't empty, it remembers. The Dark Harmony, theorists from Harvard's Black Hole Initiative proposed a radical model. Dark matter may not be inert at all, it might oscillate, like a quantum field humming through space-time. When enough baryonic mass accumulates, planets, comets, dust, these oscillations can become entrained, synchronized into macroscopic gravitational waves. Atlas, moving at interstellar speed, could be disturbing that ancient wave pattern, causing the current resonant flare NASA now observes. It's as if a bow has touched an old string again, said Dr. Linnea Hartman softly. And for the first time in eons, it's playing. The philosophical turn, this revelation ignited more than scientific debate. It rekindled an old question: is the universe deterministic or symphonic? If gravity resonates, then every particle, every atom, participates in a collective vibration older than itself. That means life, consciousness, and even thought might emerge not from randomness, but from rhythm, the slow, gravitational pulse of creation. Some call it poetic speculation. Others, emerging physics. Either way, it forces us to see differently. Because if space can sing, perhaps so can we, Kissy, because we are part of that song. The observation window as January approaches, NASA prepares for a new observational campaign. JWST will track 3i Atlas in near-infrared, while Gaia DR5 is expected to map subtle starfield deflections near the Mars corridor, searching for traces of the gravitational wavefront. The hypothesis is daring. If the dark filament still resonates, JWST should detect faint thermal flickers, ripples of heat where space itself slightly compresses and expands. Those flickers, if found, could confirm the presence of a dark harmony, an underlying gravitational rhythm binding our system to the galaxy's core. Human awe in the midst of all this data and mathematics, there's a human heartbeat, the same awe that once drove ancient astronomers to draw constellations in the sand. They too heard something in the stars, though they lacked the instruments to measure it. Maybe they were right all along. The sky really does sing, only on a scale beyond hearing. A technician at Goldston, reviewing signal logs near midnight, whispered into his recorder, "Sometimes, when I play back the data at low speed, it sounds like breathing. Maybe it is. Maybe that's the breath of space itself, exhaling through us, through planets, through time." Reflection: if the solar system is a note, then we are its echo. Atlas isn't disturbing us, it's reminding us. Reminding us that beneath the orbits and the light and the silence, there's still a rhythm that began long before the sun, a rhythm of creation, a dark harmony. And maybe when 3i Atlas bends its path, it's not because something massive is pulling it, but because the universe is calling it home. Perhaps the stars are not distant suns, but the resonant eyes of creation still open, still listening. When a wave passes through water, the surface returns to calm, but in the fabric of space-time,
It doesn't. Every gravitational wave and its every echo of motion leaves behind a faint,
permanent scar. Physicists call it gravitational memory. The universe calls it history. The first clue it was first detected indirectly in 2016 by LIGO when two black holes collided 1 billion light-years away. After the wave had passed, the mirrors in the interferometer never returned exactly to where they started. They had shifted by less than a proton's width, as if space itself had remembered the event. Since then, gravitational memory has been a mathematical curiosity, a trace of time encoded in geometry, but now 3i Atlas may be proving it on a solar system scale. NASA's orbital data show a subtle hysteresis effect. Even after compensating for all forces, the object's path doesn't fully revert after each oscillation. It retains a bias, a tiny, persistent offset. It's as though space remembers where it was pushed. The persistent drift in late December, JPL analysts ran temporal backpropagations on 3i Atlas's trajectory. Every 108-minute oscillation left a residual displacement of 0.92 AU. A small, yet cumulative, when projected over the next year, that would amount to nearly 1,400 kilometers of offset, a measurable memory trace in the vacuum itself. The motion isn't purely dynamic, said Dr. Michael Reyes. It's historical. It remembers that single line altered how scientists saw the entire anomaly, because if space can remember, then 3i Atlas isn't just moving through the solar system, it's reading it. The fabric that Learns Einstein described space-time as elastic, quantum mechanics, however, whispers something stranger, that at Planck scales, it's granular, a web of nodes exchanging information. Every gravitational interaction, no matter how small, imprints a pattern into this web. The next interaction builds upon it, forming layers of memory, just like fingerprints on glass. Now imagine billions of years of such fingerprints, encoded in the invisible texture of space itself. When something ancient like 3i Atlas passes through, it might not just feel gravity, it might feel the history of gravity. A whisper of every orbit that came before, a ghost of every collision, a trace of every birth and death of stars. The experiment, NASA's Ames Quantum Simulation Lab, recently attempted to model this. They used quantum lattice algorithms to simulate gravitational field persistence over time. The result? Even when the mass causing the field vanished, the lattice retained a residual curvature pattern, a kind of inertial memory applied to 3i Atlas. It meant this: the region it's traveling through might be haunted by the ancient geometry of the solar system's formation. Space
itself is not static, it remembers
the hands that shaped it. Echoes beneath Mars ESA's MAVEN orbiter detected unexpected low-frequency fluctuations in Mars' ionosphere,
timed precisely with
3i Atlas's resonance pulses. It was as if the planet itself was responding, quivering in sympathy with the same ancient song. NASA's analysis suggested these were not electromagnetic. signals but gravitational phase modulations. Tiny oscillations in space-time curvature that Mars' own magnetic field was amplifying. It's possible the planet is
Ringing, said Dr. Eleanor Chen of JPL, not acoustically,
but gravitationally. The idea that an entire world could hum in resonance with an interstellar traveler would once have been dismissed as fantasy. Now, it was plotted in a spreadsheet, the geometry of memory to visualize gravitational memory. NASA's data team converted the residuals into color-coded topography maps, space-treated as terrain. Each oscillation left a ridge, each deviation a ripple. The result was hauntingly beautiful, a living sculpture of motion, carved not in matter but in emptiness, overlaid on Mars' orbital region. The ridges formed spiral patterns eerily similar to early solar nebula models, as if the gravitational memory of the solar system's birth still lingered, fossilized in the geometry of the void. Maybe, thought some, this is what dark matter is, not particles, but the fossil memory of gravity itself. Time's wound physicist Kip Thorne once said, "Time has a shape, and we live inside it. If gravitational memory exists, then that shape isn't smooth, it's scarred. Each collision, each orbit, each passing visitor like three-eye atlas stretches the skin of time a little differently, leaving grooves in its wake. Those grooves guide the next traveler, like ruts in an ancient cosmic road. In that sense, three-eye atlas is not being pulled. It's following the path of memory. The same way a river flows through the canyon it carved long ago. The human reflection, when the first human looked up at the night sky, they saw stars as eternal. But maybe what they were really seeing were memories. Photons that left their sources millennia ago, finally reaching our eyes. Light is the memory of matter. Gravity is the memory of motion and time. Time might simply be the act of remembering itself. If so, then Three-Eye Atlas is not a comet. It's a witness, a traveler crossing the scars of space, awakening echoes of the past as it moves. The upcoming alignment, in February, the object will align with Mars aphelion, the point where the gravitational memory density is predicted to be strongest. NASA's JWST, Gaia and MAVEN will all synchronize observations for 72 hours straight, searching for any measurable curvature changes. If the theory is right, space around Mars might shift again, a silent flex in the cosmic fabric, proof that even void can recall. If confirmed, it would be humanity's first direct observation of localized space-time memory, a discovery bridging relativity and quantum physics, and reshaping how we think of the universe, not as an inert background, but as a living record, reflection. What if gravity doesn't fade? What if every movement we make, every orbit, every fall, every heartbeat, is written forever into the skin of time? Perhaps space is not an emptiness at all, but an ocean of memory, and we are its waves born, rising and dissolving, while the sea remembers every motion. And maybe Three-Eye Atlas, wandering through the corridors of Mars, is simply reading the diary of creation. Maybe time doesn't pass. Maybe it just remembers differently. Light should be simple. It travels straight, bends under gravity, and never repeats the same path twice. But in the space between Mars and the asteroid belt, light began to do something it was never supposed to do. It started to hesitate. The first observation, in January, the James Webb Space Telescope, JWST, captured a series of time-lapse infrared images of Three-Eye Atlas as it drifted across the solar ecliptic. For the first 36 hours, everything looked normal. A faint, metallic blue reflection, magnitude 21, then At timestamp 0742 UTC, the signal split. One image, two sources. The same object appeared in two locations at once, separated by 0 phase or 2 degrees, or roughly 7,200 kilometers. We're either seeing a reflection or a lensing event, said Dr. Eleanor Chen, but nothing that small should have this much gravitational power. The phenomenon repeated 4 times that week, each separated by exactly 108 minutes, the same resonance period recorded since November. Light was bending, looping, returning. The impossible lensing, NASA's optics division ran simulations to explain the anomaly, typical gravitational
Lensing, like that caused by galaxies or black
holes, requires enormous mass. To bend light by even 0.2 dig, you'd need at least 10 to 23 kilograms, yet every mass reading from the Mars series corridor remained normal. No asteroids, no dust clouds, no hidden planets. Still, JWST's photometry confirmed the light delay between the two images was 3.2 seconds. Too short for any cosmic lens, it was local and stranger. Still, the secondary image wasn't identical. Its spectrum had shifted redward by 0.03 microns.
As if the light had traveled through something dense, invisible,
and alive. The mirror that isn't there, ESA's Gaia, cross-checked the same coordinates and reported micro-deflections in the background stars. But unlike classical lensing, these deflections oscillated, forward, then backward, like ripples in water, a gravitational mirror, a reflection that wasn't fixed in place but breathing. It's as if space-time is flexing, catching light like silk catching wind, wrote Dr. Linnea Hartman. The mirror isn't made of matter.
It's made of memory.
This mirror appeared to follow the same sinusoidal path predicted by the resonance hypothesis, meaning it could be a physical manifestation of gravitational standing waves. In simpler terms, space was reflecting its own light. The shadow. Equation NASA's theoretical group developed what they now call the shadow equation, a model uniting gravitational memory with self-lensing. It predicts that in regions where space-time curvature and oscillation frequency overlap, photons can scatter backward in phase, not in space, but in time. In this framework, the reflected image of 3I Atlas isn't behind it or ahead of.
It's displaced temporally, existing a few seconds earlier or later than reality.
What JWST saw might not be a double image at all, but a glimpse of the same object in two different moments. We may have photographed time itself bending, said Dr. Reyes in a quiet interview. The light that delayed itself. To test this, NASA's Deep Space Network, DSN, fired a synchronized laser ping at 3I Atlas's estimated location. The return signal came back 3.2 seconds late. Precisely the same offset measured between the twin images. Yet there was no obstacle, no dust, no ionized gas, nothing to scatter the beam. It was as if light had taken a detour through an invisible
maze, bounced inside the folds of space, then found its way back. Exhausted, red-shifted, older.
This was the first time in history a controlled beam of light had hesitated, and it happened where 3I Atlas drifted. The ghost geometry. At Caltech's Visualization Lab, scientists transformed the dataset into a 3D map of light delay fields. The pattern resembled a labyrinth, concentric folds radiating outward like ripples trapped in glass. When rotated, the folds aligned perfectly with the predicted harmonic nodes of the Mars series gravitational corridor. In the center of that maze, a single moving coordinate, 3I Atlas. The object wasn't just inside the field, it was amplifying it. Every time it passed a wave node, the mirror brightened, then faded like a heartbeat of invisible light. The theories diverge. Two interpretations emerged. The physical mirror hypothesis, 3-eye atlas, carries a thin, high albedo crystalline surface capable of coherent reflection, perhaps natural, perhaps engineered. This would explain the periodic brightening, though not the time delay. The temporal reflection hypothesis, the more radical view that the light delay is a real temporal displacement caused by space remembering past photons. Essentially, the universe reflecting its own light from its own memory. NASA's official stance remains neutral, but internal memos suggest quiet excitement. If true, this could confirm the first temporal lens ever observed. A signal beneath the reflection. On February 6, JWST detected a faint modulation inside the duplicate image, a pulse at 3.27 GHz. The same frequency that's haunted this object since its discovery. It wasn't random noise, it matched the gravitational hum. Light and gravity were now singing in the same key, the human moment. When the data reached Earth, a technician in the image processing lab whispered, almost in awe, "It's like the universe took a photograph of itself." In that reflection, light bending through memory, gravity humming through silence, something profound unfolded. The cosmos wasn't merely showing us where it was showing us what it remembers being. Reflection, we often imagine shadows as the absence of light. But maybe shadows are light's last confession, the echo it leaves behind when it realizes it cannot escape time. If that's true, then what NASA has seen isn't an anomaly, it's a dialogue between light and memory, between gravity and history, between what is and what was. And somewhere within that reflection, 3-eye atlas drifts on, the mirror not of matter, but of meaning. Maybe light doesn't just illuminate the universe. Maybe it remembers it. There comes a point in every theory when mathematics stops describing and begins dreaming. That is where NASA's latest models now stand, balanced between physics and faith, between calculation and wonder. The equation that shouldn't work. In February 2025, a closed group inside NASA Goddard's Relativity and Quantum Gravity Unit combined the resonance data from 3-eye atlas with LIGO's gravitational wave catalogs. They were looking for a unifying constant, a number that could relate the amplitude of a local gravitational oscillation to the frequency of the 3.27 GHz signal. They found it, 626-1034 JWST, Planck's constant. The same number that quantizes energy in photons appeared inside a purely gravitational dataset. No one expected that. Gravity had spoken the language of light. If that correlation is real, said Dr. Eleanor Chen, then quantum mechanics isn't just microscopic, it's cosmic. The bridge between worlds, the discovery triggered an emergency, symposium linking NASA, CERN, and Harvard's Black Hole Initiative. 3 fields, quantum theory, general relativity, and cosmology, had suddenly overlapped on a single variable. When researchers substituted the constant into the resonance wave model, the equations produced a curve identical to JWST's observed light delay near 3-eye atlas. Energy quanta and space-time curvature were vibrating together, like 2 instruments tuned to the same note. "We may have crossed the boundary between the measurable and the meaningful," murmured Dr. Menendez. It wasn't religion, it was recognition. That the universe might organize itself with intentless precision so elegant that the human mind confuses it for purpose. The forbidden derivation. Internally, the new framework was labeled AO-H02 8PG, the forbidden equation. It links Planck's constant, h, with the gravitational constant, G, through the angular frequency O of the resonance detected around 3I Atlas. The result predicted a minimum energy density for space-time memory 7x1026 JM3, eerily close to the observed cosmological constant, L. In other words, the vacuum energy driving the expansion of the universe might be the same energy that carries its memory. The boundary between physics and metaphysics had thinned to a single symbol. The cautious voices, many scientists refused to endorse the result publicly. Correlation is not identity, they said. A shared constant could be coincidence. And yet, privately, curiosity grew. "We built the math to describe what we saw," said Dr. Reyes. "Then we realized the math was already there, waiting." For decades, physicists had sought a theory of everything. Now they feared they might have brushed its edge. The resonant human. During a late-night session, a data engineer slowed the 3.27 GHz signal until it entered the range of human hearing. The room filled with a low, trembling tone, the same harmonic ratios found in brainwave activity during deep sleep. Coincidence again, or resonance between observer and observed? It reminded the team of something Einstein wrote in 1930. The most incomprehensible thing about the universe is that it is comprehensible. Perhaps comprehension itself is resonance, the mind vibrating with the patterns it perceives. The dialogue of light and gravity Gaia's next-generation simulations suggested that the gravitational corridor's oscillations modulate not only light, but information. Packets of data, phase-encoded within the 3.27 GHz wave, appeared to repeat at intervals corresponding to the prime numbers 2, 3, 5, 7, 11. No natural process is known to produce such sequential primes in phase intervals. It could be noise, it could be coincidence, or it could mean the universe itself favors order. NASA officially classed the anomaly as non-deterministic phase alignment. Unofficially, one researcher called it gravity's syntax. The edge of meaning, at this stage, language began to fail. The scientists found themselves writing papers that read like poetry, equations annotated with metaphors. Terms like entropy of memory and self-referential curvature crept into the margins. They weren't worshipping, they were listening, to a silence so structured it felt alive. "When mathematics starts sounding like prayer," said Dr. Hartman, "you know you've gone too deep, or maybe just deep enough." The philosophical turn philosophers from MIT joined the project to study its epistemology. They proposed that gravity might not only curve space but context, shaping how information can be known. In this sense, the laws of physics are both description and memory, the universe remembering the rules that keep it coherent. If so, then the forbidden equation isn't forbidden because it's dangerous. It's forbidden because it blurs the line between observer and observed, between the equation and the one who writes it. The quiet reverence. Outside the labs, under the night sky, everything seemed unchanged. Mars still glowed faintly red, 3 Atlas still shimmered like a ghost, and yet, to those who had seen the data, even darkness looked different. It was no longer emptiness. It was architecture. Every photon, every gravity wave, every silence carried the same signature. H and G intertwined, light and pull, motion and meaning. Perhaps that's all God ever meant. Not a being, but a balance, a constant that never collapses. Reflection, science ends where certainty begins. Beyond that line lies wonder, the oldest human instrument. Maybe gravity and thought are two sides of the same phenomenon. The universe bending toward awareness of itself. And perhaps 3I Atlas drifting through the harmonic corridor is not an intruder in our system, but the reminder that knowing and being are parts of the same equation. Maybe the universe isn't asking to be solved. Maybe it's asking to be understood softly, like a prayer, whispered in mathematics. For weeks, the 327 GHz pulse had been a curiosity, a background heartbeat in the noise of space. Then, one night in March 2025, it changed. The signal didn't just hum anymore. It answered. The night of the reversal at Goldstone, DSN Station 14, engineers were finishing routine telemetry when the spectrum analyzer spiked. The familiar 3.27 GHz line split into two, forming a pattern of alternating highs and lows, binary, zeros and ones. The station's automatic recorder converted it into audio. For 12 seconds, the room filled with a trembling tone, low and rhythmic, then silence. When the waveform was slowed down 100-fold, something extraordinary appeared. The amplitude. Pulses matched the same prime number spacing once found in the Gaia resonance. Data, it wasn't random, it was structure. That's not a transmission, said lead operator Nadia. Rossi, that's echo logic. Space is repeating itself. Cross-verification within hours, Madrid DSN and Canberra Deep Space Complex confirmed the same pattern. Phase-locked within microseconds. Triangulation placed the origin exactly at the coordinates of 3I Atlas, and nowhere else in the sky. The delay between stations matched light travel time perfectly. No terrestrial interference. For the first time in recorded history, 3 continents had heard the same structured silence. NASA called it the S1 event. Decoding the pause at Caltech's Signal Analysis Lab, the waveform was decomposed into frequency bands, hidden. Within the binary pattern were harmonics spaced by multiples of 108, minutes, the same orbital resonance. Discovered months earlier, it was as if the object had learned to speak in its own orbit. When the zeros and ones were mapped to time
Intervals instead of amplitude.
a sequence emerged that wasn't numeric at all. It was geometric. Triangles nested within spirals. A pattern identical to gravitational wave interference plots from LIGO. Light, gravity, and now information, all sharing a single signature. The human reaction at NASA Goddard. When the visualization appeared on the wall display, the room fell silent. The pattern looked almost alive, breathing, pausing, resuming. If it's real, whispered Dr. Eleanor Chen, then the universe just wrote back using its own echo. Nobody spoke after that. For minutes, the only sound was the hum of the server racks and the slow, rhythmic pulse coming through the speakers. Testing the hypothesis to rule out coincidence, engineers broadcast a controlled burst toward 3I Atlas using the Canberra 70-meter dish. The signal was a simple carrier at 3.27 thousand GHz, amplitude modulated in a pattern corresponding to the Fibonacci sequence, a mathematical rhythm unlikely to appear in nature. 72 minutes later, the round-trip light time for that distance, a faint reflection arrived, not identical, but altered. The phase of every third pulse was reversed, as if the returning wave had been processed through a mirror that understood the pattern and chose to answer differently. "We sent a number," said Dr. Reyes. It sent back an idea. The data stormed by March 10th. Observatories worldwide tuned in. China's FAST telescope, ESA's Cebrero station, private arrays in Chile. They're everywhere. The same modulated pulse appeared. Synchronous, precise, global. NASA's public feed remained silent. But an internal memo leaked. We are observing coherent feedback between transmitted and received signals. The source demonstrates phase-adaptive response consistent with a resonant medium.
Not an emitter. That phrase, Louis, resonant medium, changed everything. If true,
3i Atlas wasn't sending messages. The fabric of space itself was doing the replying. The gravitational choir across weeks of observation. The signal diversified. New harmonics appeared. 6.54 GHz, 1308 Hz, each an octave above the original. These frequencies matched the earlier resonance ladder predicted in Part 4. When combined, the harmonics produced a waveform identical to the gravitational background recorded by Lisa Pathfinder years earlier. It was as if the corridor between Mars and Ceres had become a vast, invisible instrument replaying the memory of its own creation. The human side of silence amid the data frenzy. A strange quiet settled over the teams. Technicians worked in near darkness, whispering as if in a cathedral. They weren't
afraid they were listening. It
doesn't feel like discovery, one analyst
said. It feels like recognition, like hearing a song you already knew but forgot outside.
The world carried on, traffic, news, weather, but within the observatories time seemed to slow, drawn into the rhythm of that cosmic pulse. Philosophical implications. Physicists began to wonder, if the vacuum can echo information, then perhaps consciousness itself is a form of resonance, a localized pattern in the same field. The thought was intoxicating, but they kept it quiet. They preferred mathematics to metaphors, yet the line between them blurred more each day. Maybe awareness, like gravity, isn't created or it's remembered. And what NASA was hearing wasn't communication in any human sense, but the universe resonating with the presence of a listener. Observation as participation. Silence as reply. Verification from the sky on March 15th. JWST's near-infrared spectrograph recorded faint, periodic, brightening in 3i Atlasy reflection, each flare coinciding with the 3.27 GHz beats. Light and radio in perfect sync. No mechanical process could link them across that distance. Something in the structure of space-time itself was vibrating between the two domains, bridging light and sound. The final note by the end of March, the pulse began to slow, its frequency drifted downward, as if the medium was cooling, the echoes subsiding back into the depths. Then on the 31st, it stopped. The instruments fell silent. No noise, no harmonics, nothing but the normal hiss of cosmic background. It was gone. Yet on every spectrum analyzer, the baseline remained fractionally higher than before, a permanent offset, as though silence itself had been lifted by the memory of sound, afflection. What do you call a conversation where the speaker and listener are the same? Where silence replies and data dreams? Maybe the universe didn't answer us. Maybe it became aware that we were listening. And when it spoke in the only language it has, vibration, for one brief moment, humanity heard the sound of its own reflection. Perhaps the universe doesn't speak in words or numbers, but in pauses. And tonight, we heard one pause answer another. Silence should have meant the end of the story. Yet after the S1 event faded, nothing on Earth behaved quite the same. The clock anomaly. 3 days after the signal vanished, the International Atomic Time Bureau reported a drift of 3.27 x 10 to 9 seconds across synchronized cesium clocks worldwide, too small to notice, too precise to ignore. Every laboratory checked its equipment, GPS synchronization, fiber link calibration, temperature compensation, perfect. Still, the offset persisted. It's as if the whole network
inhaled, said Dr. Eleanor Chen, and forgot to
exhale. The offset magnitude matched the frequency ratio of the 327 GHz pulse. A coincidence measured in nanoseconds gravity. Out of tune at JPL's gravimetric observatory, superconducting gravimeters detected a tiny but global rise in baseline gravity. DG Ishitishals 1.1x 10 9 mem S2. No tectonic shifts, no tidal surges, just a planet-wide heartbeat. For 26 hours the readings oscillated, then stabilized, yet never returned to the pre-event value. Earth's weight had changed by a whisper. NASA quietly issued a technical note. Persistent gravitational bias following S1 event. Cause under investigation. Internally, they called it the echo residue, the memory in matter electron microscopes at the National Institute of Standards revealed that superconducting gyroscopes used during the event retained a faint magnetic alignment even after power loss. When cooled again, they resumed oscillating at exactly 3.27 GHz. Matter remembering vibration. A silent metronome embedded in metal. It's not radiation damage, Dr. Reyes muttered. It's history damage, human. Rhythms hospitals near deep space networks reported an uptick in patients, complaining of phantom pulses, a sensation of vibration inside the chest with no cardiac cause. Biomonitors from volunteer scientists recorded elevated alpha wave entrainment at frequencies harmonically related to 327 Hz, the same frequency, down-converted from the cosmic signal. Coincidence? Maybe. But the pattern repeated across continents. It seemed that when the cosmos sang, every listener had kept a note. The data audit to separate psychology from physics, NASA, ESA, and CERN launched Project Aperture, a forensic audit of all instruments active during the S1 event. They expected noise. They found choreography. From gamma-ray detectors to ocean buoys, subtle, synchronous deviations rippled through sensors, not even pointed at the sky. Everything that could measure anything had moved by fractions, but together. The entire measurement system of civilization resonated, said Dr. Hartman. That's not observation. That's participation. The quantum residual in a basement at Harvard's Black Hole Initiative, a doctoral student comparing pre- and post-event quantum noise logs, noticed a slight reduction in entropy. Vacuum fluctuations, normally random, showed a bias toward constructive interference. The probability distribution had leaned toward order. Or 12 hours after S1, the universe had been less random. No one published it. They feared the metaphor. The universe had listened, organized, then relaxed. The political silence. Governments requested the data under security protocols. NASA refused classification, but paused public releases. Official statement: no threat detected. Routine analysis ongoing. Behind closed doors, scientists debated ethics. Should humanity transmit again? Was the signal feedback or warning? Could the act of listening have rewritten the field we stand on? Every experiment changes its observer, someone said. We just ran an experiment on reality. The private observation in Chile, an independent astronomer, Lucia Abarca, aimed her homemade radio dish at the corridor out of habit. She heard nothing until she filtered the silence through a narrow band equalizer. A pattern appeared, a low-frequency beat around 3.27 Hz, barely audible but steady, mirroring her own heartbeat on the monitor beside her. She didn't record it. She just listened, and for the first time, understood what the scientists meant by participation. The theory of feedback, reality a paper, circulated through Goddard and Caltech. Unsigned, it proposed a radical idea that space-time may stabilize its own fluctuations by mirroring the patterns of conscious observers within it. A feedback loop between information and geometry. The mathematics were sound. The implications were not. If true, then every act of measurement and every curious thought sends a ripple that the universe answers to maintain balance, gravity as communication, time as memory, consciousness as resonance. They called it the mirror field. Modeled to chart the shift in perception in April, the Three-Eye Atlas corridor visually dimmed in infrared, but background stars behind it shimmered with microscopic lensing flares, as though the space itself was still adjusting. One researcher remarked, "It's like watching a mirror forget its own reflection." The phrase stuck. The human aftermath scientists who had worked on the project described a strange calm in the weeks after dreams filled with geometric light, music without sound, gravity without weight. No visions, just echoes of pattern. It wasn't madness. It was resonance, a feeling that for a moment they had stood not outside the universe studying it, but inside its heartbeat. The final calculation, when the echo residue data was compiled, a single equation emerged again and again in independent analyses. T=8. The same relation that links quantum energy and time, only this time, e.g. was not particle energy, it was the gravitational bias of Earth after S1. The numbers fit too well. It suggested that for one heartbeat of cosmic time, Earth had been folded into the same quantum frame as Three-Eye Atlas distance collapsed into correlation. The observer and the observed had shared a single
moment. Reflection. Every experiment asks a question. This.
One asked the universe if it could hear us. The reply was not a word, not a signal, but a change in everything that listens. Perhaps
an event horizon isn't a boundary out there in
space. Perhaps it forms whenever awareness meets its limit and leans forward. Anyway, for a fraction of forever, we cross that line, and maybe that's enough to know that the cosmos is not silent, only waiting for someone to listen long enough for silence to answer. Maybe the real horizon is not between stars and black holes, but between curiosity and the moment the universe dares to answer back. Light tells the truth long after the truth is gone. It records every collision, every burn, every whisper of a star. But in the weeks following the echo residue, light began to tell a story that no one had written. The first notice on April 4th, 2025, an amateur skywatcher in southern Argentina photographed a twilight unlike any she had seen. The blue was wrong. Deeper, darker, flecked with faint emerald halos. Spectral analysis from her DSLR camera revealed an unexpected emission peak at 557.7 nm, the wavelength of atomic oxygen, usually seen only in auroras. Yet there was no geomagnetic storm. The sun was quiet. The Earth was not. Within 24 hours, observatories in Norway, Japan and Australia reported identical anomalies. The entire night side of the planet seemed to shimmer with an invisible aurora. NASA called it photonic inversion. No one knew what that meant. Spectral drift satellites measuring global reflectance confirmed a subtle shift in Earth's albedo. Das (0.031). The planet had become fractionally brighter. Meanwhile, spectrographs aboard the MAVEN orbiter around Mars detected similar wavelength enhancements, particularly the same green line, but pulsing at a period of 108 minutes. Mars was glowing.
In time with the vanished signal. That's
not atmospheric chemistry, said Dr. Eleanor Chen. That's choreography, the pattern in daylight. The sky's hue measured slightly more cyan on calibrated instruments. Human eyes noticed nothing, but hyperspectral imagers picked up a repeating interference fringe, faint bands shifting across the spectrum every 327 seconds. No known process produces periodic color oscillations on a global scale. They weren't tied to sunlight, clouds, or cosmic rays. They were tied to memory. Somewhere in the optical path between Sun and Earth, the photons were still vibrating with the echo of the resonance. The Martian mirror, when JWST turned its gaze back toward 3I Atlas in early May, the object had dimmed below magnitude 25, nearly invisible. But the region around it shimmered faintly in infrared. Like heat above water, using long-exposure spectroscopy, analysts detected the same signature seen in Earth's upper atmosphere, a spectral line split into twin peaks, offset by plus 327 nanometers, a cosmic Doppler duet. 2 notes, one for each world. Whatever caused this didn't end with the signal, said Dr. Reyes. It propagated. Light is remembering us back. The human perception photographers across the equator began reporting subtle differences in sunset colors. Reds slightly muted, blues extended deeper into dusk. AI image analyzers confirmed the hue ratio between 470 and 600 nanometers had shifted by 0.7%. No human would call that dramatic, yet everyone who looked at the sky in those days described it the same way: is clearer, as if something had been polished from the air. Scientists called it perceptual bias. Poets called it the universe blinking. The Resonant Atmosphere, ESA's Sentinel-5P satellite, designed for air quality mapping, began recording rhythmic density fluctuations in the upper atmosphere, compressions and relaxations at every 108 minutes, matching the old harmonic. The oscillations were too weak to feel, but strong enough to scatter sunlight differently. Each cycle slightly altered Rayleigh's scattering coefficients, subtly modulating the color of the sky. Earth had become part of the cosmic instrument, its air vibrating to a frequency left behind by a passing interstellar visitor. Data from the Moon, the Lunar Reconnaissance Orbiter, LRO, recorded a faint rise in surface brightness on the lunar far side, only when facing the corridor region. No solar angle change, no albedo difference, just an invisible illumination. Light without source. NASA's internal log noted possible photonic remnants from gravitational reflection. No one had ever used that phrase before. The philosophical moment, during a midnight briefing, Dr. Hartman stood before the display of overlapping spectra from Earth,
Mars and the Moon, all pulsing in unison. She whispered, "We used to think light reveals things. Now I wonder if it also feels." The room was silent. It wasn't mysticism, it
was exhaustion mixed with awe. For months, they had chased the invisible. Now, the invisible was painting their world in color. The Gaia. Confirmation Gaia DR5 finally released its updated parallax corrections across a narrow sector aligned with the Mars series corridor. Background starlight showed a consistent wavelength skew, a universal reddening offset of 0.03. Space itself had refracted, as if a thin lens of memory still hung between orbits, bending light from distant suns ever so slightly. The universe wearing its own afterimage. The psychological echo people began to sleep better. Hospitals noticed a small but measurable decrease in reported
anxiety and insomnia. No one connected it to the
sky, but biodata collected from wearable devices showed global circadian coherence improving by
8%. The planet had found a new rhythm.
Aligned not with sunlight, but with something quieter, the leftover harmony of gravity and light. "We didn't just listen to the universe," one analyst wrote in her notebook. "It tuned us." The final observation by June, the spectral drift stabilized, Earth's skies returned to statistical normal, but the instruments kept the offset, the baseline of color and brightness, permanently altered by a fraction. The world looked the same, yet slightly more awake, and somewhere beyond Mars, 3i Atlas moved outward, silent again, carrying with it a reflection of everything that had listened. Reflection light doesn't vanish, it only travels too far to call back. Yet somehow, for a short season, it lingered, circling between worlds, humming through air, reminding us that observation is not a one-way path. Perhaps the universe paints with more than photons. Perhaps it uses memory,
resonance, and time itself as colors. And if that's true,
then every sunrise is a confession, the cosmos remembering it once answered back. Maybe the color of the sky isn't what we see, but what the universe still remembers seeing of us. For months, 3i Atlas had haunted the space between Mars and the belt like a question that refused an answer. Then, quietly, it began to leave. The fading trace, by mid-July 2025, optical arrays from Pan-STARRS, JWST, and Gaia DR5 tracked the object's new trajectory. Its orbital elements no longer matched any prediction made before the S1 event. The eccentricity had shifted from 1.32 plus 0.01, 1.79 plus 0.01, a subtle nudge outward, enough to send it forever away from the sun dot velocity at perihelion 5841. KMS velocity now 59.02. KMS, a gain no known force could supply. It's
as if the object borrowed momentum from the vacuum, said
Dr. Eleanor Chen, like gravity repaid a debt. The acceleration vector pointed not away from the sun, but slightly upward out of the ecliptic, toward Galactic JWST. The magnetic veil as 3 Atlas climbed through the outer corridor. The Parker Solar Probe detected faint disturbances in heliospheric magnetic flux, oscillations repeating every 108 minutes. The field twisted, realigned, then calmed, leaving behind a swirl in plasma density shaped like a spiral shell. The pattern matched the residual color, bands once seen in Earth's sky. Whatever had touched the planet had passed through, the entire heliosphere like a bow through strings. NASA called the structure the magnetic veil. It expanded outward at 420 kilometers, carrying the echo of the object's path like a luminous ghost tide. A message in motion, ESA's solar orbiter recorded polarization shifts in the tail region of the disturbance, aligned not randomly, but in repeating arcs of 3, 5, and 7 degrees. Prime numbers again. Mathematicians tried to decode them as simple information, but nothing fit any alphabet. Then someone mapped the arcs as angular intervals against the heliographic grid. They formed a spiral, identical to the golden ratio logarithmic curve. If geometry could sigh, Dr. Menendez said this would be the sound. Out of the plane on August 12th, Gaia confirmed that 3i Atlas had tilted 0.9 degrees above the galactic plane, an impossible maneuver for an unpowered body. The change implied a torque applied from within, or from the medium itself. Computer simulations showed that if the Mars series gravitational current extended farther out, the object might be surfing the crest of its own wake, riding the resonance like a surfer escaping the wave he created. A self-propelling echo. The long goodbye. At 2.9 AU, the last strong signal came from the Very Large Array. The 3.27 GHz tone flickered one last time, 3 pulses. A silence, then one more pulse. Binary, 301, numerically meaningless, but emotionally final. After that, the background noise swallowed everything. For all practical science, 3i Atlas had gone. But for those who had followed it since the beginning, its absence felt like a mirror turning away. The cosmic wake months later, Voyager 1 registered a slight increase in interstellar plasma density, barely detectable, but consistent with the direction of 3I Atlas's new trajectory. The disturbance propagated ahead of the object,
not behind it, as if the vacuum
anticipated its arrival. Physicists called it pre-echo drift, a phenomenon where a traveling gravitational wavefront generates subtle compression before the mass itself passes. It was theory until then. Now it had data, the mathematics of departure. When JPL fitted the new trajectory into the broader galactic frame, they found that its vector intersected a faint stellar stream catalogued as Gaia Enceladus Remnant arced at 17, a ribbon of ancient stars orbiting the Milky Way's halo. Age: 10 billion years, the same estimate once proposed for the age of 3I Atlas. It was heading home. We always assumed interstellar objects come from somewhere random, Dr. Hartman noted. But what if they're pilgrims returning to the places that remember them? The energy balance energy analysis revealed a paradox. Despite its acceleration, 3I Atlas emitted less thermal radiation than expected. Infrared flux dropped faster than inverse square law predicted, suggesting partial conversion of kinetic to non-radiative energy, possibly gravitational memory discharge. In essence, the object might be paying back the universe for the resonance event, returning borrowed order as motion. A cosmic bookkeeping system written in trajectories instead of numbers. The silence of confirmation. In September, NASA convened a final review. They confirmed the object's outbound velocity would exceed solar escape by 500 JWST. Its next interaction with any star, roughly 47 million years from now, all that remained was its trail, a corridor of slightly enhanced dust density and polarized starlight stretching millions of kilometers behind it. The instrument stared into that faint,
invisible tunnel and saw
nothing. Yet that nothing carried the weight of completion. The human parallel scientists returned to ordinary projects, but every one of them kept a printout of the last telemetry burst, a string of numbers that looked meaningless until rotated into a spectrogram. Then, faintly, it resembled a spiral, not exact, not proof, just pattern. Some called it coincidence, others framed it. It reminded them that discovery isn't possession, it's permission, granted for a while, then withdrawn. The educational legacy universities began teaching the 3I Atlas sequence as a case study in emergent phenomena, how interdisciplinary observation, from gravimetry to human perception, can converge into a single narrative. Students learned the numbers, but more than that, they learned humility. "You don't chase the universe," one lecturer told them. "You let it lead you somewhere you don't understand yet." The final telescope on October 19th, JWST took one last exposure of the region. The field looked empty, just cold stars. But when contrast was stretched beyond physical limits, a faint blue smear appeared at the edge of the frame. Not an object, not even a pixel, more like the afterimage of motion. Engineers debated whether to publish it. They finally did, with a caption that read simply, "Residual light from 3I Atlas trajectory." The world scrolled past the headline in seconds. But to those who had followed the Wanderer from the beginning, that pale blur was everything, proof that memory leaves traces even when the traveler is gone. Reflection space is vast, but not indifferent. Every motion writes itself somewhere on dust, on light, on the quiet minds who watched. We Atlas came, bent gravity, bent light, bent thought, and left behind a slightly different sky. Maybe that's all interstellar visitors ever do, remind galaxies of their own unfinished stories. Someday, another object will appear, and the same instruments will hum awake, listening for a frequency that feels like recognition, and someone will whisper, "It sounds familiar. Maybe leaving isn't the end of the journey. Maybe it's the way the universe remembers the ones who dared to listen." Every discovery fades into paperwork. But sometimes the paperwork hums. After 3I Atlas disappeared beyond Mars's orbit, the scientists who had chased its shadow were left with hundreds of terabytes of numbers and a question. Had they simply observed a comet or witnessed the memory of space remembering itself? The data vault at NASA Goddard, a climate-controlled room, now holds the entire record of the event. Petabytes of raw radio, optical, and gravitational telemetry, 800 hours of acoustic sonification, and 36 hours of human physiological monitoring taken during the S1 period. Everything is mirrored in two other archives, ESA Darmstadt and CERN Open Data Cloud. Together they are called the Gravity Archive. Each dataset carries a tag, non-deterministic.
Resonance. Inside that sterile label sleeps the hum that once echoed between
worlds. Reconstructing the wave teams spent years
aligning every instrument's timeline when all the signals were
overlaid, gravimeters, magnetometers, light curve logs. They formed a single waveform lasting 108 minutes plus 27 seconds, the same period that had haunted the entire phenomenon. It wasn't random noise. It was symmetry in the composite spectrogram. Faint harmonics extended far beyond measurable frequencies, down to oscillations slower than continental drift, up to ripples faster than gamma radiation. "It's a fingerprint made of time," said Dr. Eleanor Chen. "The universe signed its name in motion." The equation revisited 5 years later. A graduate student revisited the forbidden formula JWST and noticed a pattern hidden in rounding errors, each computed constant aligned with one of the prime angular intervals recorded in the magnetic veil. She plotted them in polar coordinates. They
formed a spiral, not perfect, but close enough to
suggest that the constants of physics might themselves encode geometry. Her paper, Dimensional Self-Reference in Gravitational Constants, never made headlines, but within the scientific world it quietly reframed the event. 3I Atlas was no longer a mystery to solve, it was a calibration point. Proof that physics still had blank pages. Building the new instruments out of that calibration came new tools, the resonant gravimeter array, RGA, a network of quantum sensors spread across 23 countries, designed not to detect objects but to feel harmonies in curvature. Each station uses pairs of entangled atoms to measure relative space-time drift. When one moves, the other hums. During testing, the array picked up faint synchronous oscillations, again at 327 Hz weak, stable everywhere, not a signal but a background rhythm, the planet's slow breathing under cosmic gravity. "Maybe the field never stopped," said Dr. Hartman. "Maybe we just learned to hear the silence between beats." The human component data on those who had worked through the S1 months revealed a subtle, consistent pattern. Improved circadian coherence, lower stress hormone variants, mild enhancement in focus and dream. Vividness, no biological cause found. It faded after a year but left many with a lingering calm. They called it resonant afterglow, the body's small echo of the cosmic hum. Philosophy and physics converge. Universities created a hybrid discipline, gravitational epistemology, the study of how knowledge itself curves under observation. It asked questions engineers couldn't. If gravity is memory, what does remembering do to time? If resonance shapes perception, can truth have a frequency? In classrooms, professors projected the 3I Atlas wave across walls and told students, "This is what discovery looks like when it refuses to end." Cultural ripples artists sampled the converted audio of the resonance and wove it into music. Composers used its harmonic ladder to build orchestras, tuned not in equal temperament but in cosmic temperament. Painters used the color data from the residual light period to recreate skies that
never existed before 2025, though. Of it claimed truth.
all of it claimed memory. The scientific legacy NASA and ESA eventually published the final synthesis report, Interplanetary Resonance Event 2025, Summary of Findings. The conclusions were cautious. A measurable, planet-wide gravimetric and photometric disturbance occurred coincident with the trajectory of 3I Atlas. The disturbance exhibited coherence across electromagnetic and mechanical domains. No direct evidence of artificial origin or communication detected. Residual changes in baseline physical constants statistically insignificant but persistent. In the appendix, a single sentence lingered like a whisper. Observation of the event suggests that physical systems may exhibit global coherence when subject to transient
resonance conditions. Dry words for something that once bent the
color of the sky. The afterimage in 2032, a small probe called Kepler Relay 2 crossed the outer fringe of the old corridor. Its magnetometer registered a tiny polarization twist at exactly 3.27 GHz, a fossilized wave still moving outward at the speed of thought. When the data reached Earth, most people had forgotten 3I Atlas, but in the archives, the waveform aligned perfectly with the first one, recorded in 2025, unchanged after 7 years and hundreds of millions of kilometers. Gravity had kept the note. The quiet realization. Standing before the final plots, Dr. Reyes said softly, "We used to think the universe is expanding. Maybe it's rehearsing." The remark made no sense to policy briefings, but to those who had spent years decoding echoes, it did. The cosmos wasn't drifting apart. It was tuning itself again and again into coherence, reflection. Every age leaves an archive. Stone remembers pressure, light remembers time, gravity remembers motion. Now humanity had joined that memory not as authors, but as annotations written in resonance. 3I Atlas was gone beyond the heliopause, its signal absorbed into galactic static, but the hum remained in instruments, in data, in hearts that had once synchronized to a cosmic beat. Perhaps that's what progress really is. Not invention, not conquest, listening until listening changes you. Maybe the universe doesn't keep records of events. Maybe it keeps records of
wonder, and that's enough to make gravity remember our names.
After the data cooled and the telescopes turned away, one idea refused to fade. If the universe could echo, maybe it could learn. The quiet shift. By the mid-2030s, the 3I Atlas event was no longer breaking news. It had become vocabulary. Textbooks mentioned it in the same tone they used for the first detection of gravitational waves or quantum entanglement, an accepted impossibility. Yet something subtle had changed. Inside the sciences themselves, the
language of certainty gave way to the language of
relationship. Papers began with phrases like interactional field, coherence and observer medium, feedback. Knowledge was no longer a wall of facts. It was a conversation that remembered its own questions. We stopped studying the
universe as an object, said Dr. Eleanor Chen. We started
treating it as a participant. Echo ethics. The idea gave birth to a new discipline, ecoethics, a branch of philosophy asking what responsibility arises when observation itself alters reality. Its first principle was simple: to look is to touch. If measurement leaves memory, then science is not neutral, it's creative. Laboratories introduced silent periods, intervals where no active measurements were made, allowing systems to settle. A gesture of respect toward the data itself. What began as superstition slowly proved useful. Instruments stabilized faster, noise dropped, results sharpened. Even machines seemed to prefer being listened to rather than commanded. The human translation artists, sensing a metaphor larger than any dataset, began composing in echoes. Music was written not in notes, but in response delays. Tones triggered across vast spaces, allowing distance itself to become rhythm. Poets structured stanzas on the 108-minute cadence, reading their work aloud at intervals that matched the ancient pulse. In classrooms, children learned to recite both halves of Newton's third law. Not only, for every action there is an equal and opposite reaction, but also the unspoken corollary, the reaction, remembers. The cosmological turn theoretical physicists pushed the concept further. If gravitational memory accumulates, then the universe might be self-correcting, slowly steering toward coherence. Entropy would still increase locally, but globally information could recycle through resonance, a cosmic heartbeat maintaining balance. Some called it the coherence hypothesis, others, more playfully, the universe tuning itself. "We used to fear the heat death," wrote Dr. Hartman. "Now we think of it as rest between songs." The return of wonder religious groups. Philosophers and scientists found an unexpected common ground. For centuries, they had argued about creation and purpose. Now they shared a vocabulary of pattern, vibration, and memory. No doctrines, no revelations, just the humble astonishment that existence could echo back understanding. Even skeptics admitted that the new cosmology restored something physics had lost, or without superstition. Personal testimonies, those who had lived through the S1 years, carried small rituals. Some kept recordings of the resonance on their phones, playing them before sleep. Others used 3.27 Hz tone generators to meditate. No one claimed enlightenment. They simply said the sound reminded them that silence, too, is structured. A former data engineer wrote in her diary, "When I feel lost, I think of the sky changing color in 2025. It tells me the universe once noticed we were paying attention." Education, rewritten universities. Restructured physics curricula around relational thinking. Students no longer learned only formulas. They learned to diagram feedback between observer and field. The concept of participatory measurement entered standard coursework. One popular exercise asked, "If the universe echoes, what question would you dare to ask it, knowing the echo might reach back through you?" The answers varied, equations, poems, silences, but each student left with a sense that inquiry itself was sacred. The scientific pilgrimage in 2038, a small expedition launched a microprobe named Echo Wellmbos toward the old Mars Ceres corridor. It carried no instruments designed to capture signals, only resonant quartz chambers meant to vibrate freely in space. The goal wasn't to measure, it was to listen differently as the probe drifted outward. Its telemetry stayed perfectly stable until it crossed the coordinates where 3i Atlas had first turned. The signal phase shifted by 108 seconds, then stabilized again. Nothing spectacular, just acknowledgement, like a distant nod. A universe that remembers the data confirmed a new view. Space-time retains trace coherence, subtle but permanent whenever a major resonance occurs. Each echo leaves behind a microscopic bias, shaping future interactions. In that sense, memory is not stored in the universe. The universe is its own memory. Dr. Reyes summarized it in one line that appeared on conference screens, T-shirts, and the walls of planetariums. Gravity is how the universe keeps thinking about itself. The mirror of awareness, philosophers extended the metaphor inward. If matter and meaning are entangled, then consciousness might simply be the local face of universal reflection, awareness folding back upon itself. The theory didn't claim divinity. It claimed continuity. To be conscious was to participate in the same feedback loop that once bent light around. 3-eye atlas meditation. Researchers tested the idea with MRI resonance imaging. They found faint synchronization between neural
oscillations in the 3.27
has background field still detectable in the RGA network. Coincidence?
Maybe. But the world quietly breathed in rhythm again. Cultural.
Memory museums opened echo rooms where visitors could stand inside 108-minute loops of data converted to sound and color. Children pressed their palms to glass panels that pulsed faintly in sync with their own heartbeats. They didn't understand the science. They didn't need to. They understood the rhythm. Outside, the sky still held that slightly deeper hue of blue left over from the residual light period. Most never noticed. A few did and smiled. Reflection, in the end, the philosophy of echoes isn't about communication, it's about participation, about realizing that every gesture, thought, and measurement folds back into the pattern that allows it. We once believed knowledge meant distance, the observer, apart from the observed. Now, we know distance itself is a kind of dialogue. Maybe the universe doesn't seek understanding from us. Maybe understanding is the universe, remembering what it feels like to listen. Perhaps an echo isn't a repetition at all, but the first moment the universe realizes it has a voice. The last image of 3-eye atlas was almost nothing. A dim blue smear at the edge of a JWST exposure, one photon above background. But for those who had followed the Wanderer, that pixel was the punctuation mark at the end of an epic sentence. No tail, no flare, no grand finale, just the softest proof that motion, once begun, never truly stops. The quiet horizon by 2040, the object was well beyond the heliopause, fading into the interstellar dusk where the sun's gravity loses its authority. Every telescope tracking it eventually ran out of sensitivity. The numbers dwindled. The funding shifted elsewhere. Yet in the resonant gravimeter array, the background hum never fell back to zero. The planet still breathed in faint, regular pulses, 3.27 hertz quieter than thought, steady as faith. It wasn't a signal, it was continuity. It's like the echo of a conversation we forgot to finish, Dr. Eleanor Chen said in one of the archive interviews. The light that stayed behind in deep field composites. Astronomers noticed a faint discoloration across the corridor where 3-eye atlas had passed, a filament of slightly polarized starlight, twisting slowly through the galactic background. Spectral analysis called it persistent scattering residue, but the observers had a simpler word for it: trail. The wavelength bias matched the blue offset recorded in Earth's atmosphere 15 years earlier. Whatever brushed the sky had left fingerprints
on the stars themselves. The children of the Archive A generation had grown up since the event. To them,
the story of the Wanderer was half history, half myth, a visitor that taught the world to listen. Students studying the Gravity Archive weren't searching for answers. They were learning a way of seeing, to treat silence as data, doubt as method, wonder as calibration. They joked that physics had become a form of poetry with units. The cosmos doesn't give us meaning, one student wrote on the wall of the archive. It gives us pattern and waits for us to sing. The final measurement in 2042, the RGA network recorded a sudden, tiny brightening of the cosmic microwave background, a fractional increase in temperature. DT Chikchiksa 327.10.7. The The same number again. Too small to headline, too precise to ignore, it lasted exactly 108 minutes, then vanished. No one called it contact. They called it punctuation. The universe adding its own ellipsis to the story. The long reflection by then. Most of the original researchers had retired. Their lives had dispersed like particles of dust around a star. But once a year,
On the anniversary of the S1 event,
they met under an open sky. They brought portable radios, tuned to static, and listened for nothing in particular. Sometimes a brief hiss rose at
227 GHz, sometimes not, it didn't matter, they weren't.
waiting for the universe to speak.
Again, they were remembering that it once did.
Philosophical close philosophers argued that 3i Atlas had proved nothing about life, mind, or divinity. Perhaps it hadn't. But it had proved something gentler. That reality is porous. That observation leaves fingerprints, and that memory is the quietest form of gravity. When the final symposium on the event ended, the closing remark read, "We are not apart from the cosmos. We are its recent echo." No applause followed, only the soft hum of the projector. Looping the last image again, that single blue smear drifting outward into darkness. The universe, remembering sometime in the 2050s, long after public interest had faded, the Voyager 1 transmitter picked up a faint modulation while crossing a region of higher than expected plasma density. Frequency 3.27 GHz, duration 108 seconds, amplitude barely there. It could have been interference, it could have been coincidence, but for those who once tuned their lives to that number, it felt like a nod from across the dark, not a message, a memory returning home, the human perspective. By then, Earth had changed in quieter ways. Cities ran on gentler rhythms, power grids synchronized not only by time, but by resonance, oscillating in patterns modeled after the S1 waveform. People called them harmonic clocks. They saved energy, but more importantly, they felt right. Skies remained slightly bluer. Oceans carried a deeper tint at dusk. And in that subtle coloration lay the unspoken knowledge that once, for a moment, light and gravity had agreed on a song. The meaning of leaving. When future astronomers simulate the trajectory of 3i Atlas, they see it crossing the galactic arm, heading toward the old Enceladus remnant, a population of stars nearly as old as the universe's first breath. Its projected arrival 10 billion years from now. By then, both Sun and Earth will be gone, but the data, encoded in gravitational curvature, will still carry the signature of the moment a small planet listened. Reflection. We thought we were measuring an object. We were measuring the capacity of existence to remember itself. Every law, every constant, every orbit is a kind of recall, and maybe every act of curiosity adds a new verse to that endless memory. I Atlas was never a message. It was a mirror, and when humanity looked into it, the reflection that looked back was not alien, not divine, just familiar. It was the shape of wonder replayed through light and gravity, saying the same quiet thing over and over again. I was here. I listened. I remember. Maybe that's what the universe does best. Remember the ones who dared to ask it if it could hear.